Good morning, students. Welcome to chemistry. Chemistry is the essence of science, and beyond chemistry, there is no science. And the word alchemy is a miracle in chemistry. Have you read Alchemist by the famous Brazilian writer Paulo Coelho? The writer himself dreamed of an artistic career, and Alchemist is the best seller in the history of Brazilian literature, not only in the history of Brazilian literature, but in the world's literature. It's a story of a small boy, Santiago, from Spanish province. He is dreaming of wandering through the world in search of a treasure. And finally, what happens to his dream? You need to go through this novel. And there are two words coming here, is alchemist and alchemy. The word alchemy. Alchemist by Paulo Coelho. Our assignments from this one is what's alchemy, who is alchemist, and what this story gives to you as a chemistry student, and is there any resemblance between the small boy Santiago and the writer himself? So next week we are expecting these assignments. Universe is a miracle. There are many problems in universe, just like expanding universe and explosion of supernova and falling of meteors, earthquake. Many things are there, and these have no solutions. But we come towards Earth, many other problems like political problem, environmental, societal, and many have some solutions. So thinkers say every problem there is a solution. But we are going in the reverse direction, that first we are considering the solution and then go to the problems behind solution. So let's consider solutions. The definition of solution is it's a homogeneous mixture of two or more substances, and its concentration can be varied within a certain limits. So it's a homogeneous mixture of two or more substances and its concentration can be varied within certain limits. Whenever we are considering a definition, we need to consider each and every word in that definition. So we need to consider here what's homogeneous. It's a homogeneous mixture, and the second word is mixture of two or more substances, and its concentration can be varied within certain limits. These are the important words. For that, let's first make a liquid solution. We are taking a vessel and water. Our first component and major component is water. It's in liquid state. It's the major component. And now we are going to um, make an orange juice. So our second component should be orange juice. It's also in liquid state. And the third component, sugar, for some sweet taste. But it's in solid state. It's in solid state. Three components are there. One is major, and it is called, the major component is called solvent. Always. And this is solute, and this is also solute. Component A, B and C, we are getting a perfect solution. If it's a perfect solution, it should be homogeneous. What's the word meaning homogeneous? If you are taking some solution from here in the bottom, it is sweeter than the above solution. Its density is varying with the rest of the solution. It's not called homogeneous. For a homogeneous mixture, the composition, all the characteristics are equal or same throughout the solution. Then it is homogeneous. Okay, I also get a pinch of orange juice here. And with your permission, I'm going to take this one. Okay, but I need more sugar. So yeah, I am going to change the concentration by adding more sugar to it. I'm going to change the concentration. So it's the concentration can be varied. And before that, one more word is coming. That's mixture. You know how to differentiate between an element, compound and mixture. In a mixture, there is no bond between the molecules. Here in this case, between the solvent and solute molecules, there is no bond. That's a mixture, and the concentration can be varied. How we vary the concentration? By adding more substances, more component, one or two component, we get different concentration within certain limits. That means there is some limits are there, just like temperature or physical properties and chemical properties. If it is above the limit, the solution will not exist. Here it obey all the definition here. Therefore we are getting a particular, that means a definite solution, a perfect solution from this. That's a liquid solution. So the terms we came through is solvent, and it's the major component, and it determines the physical state, which determines the physical state. And the minor component is the solute. Solute is the minor component. And we get a liquid solution. Some patients are there, they need sodium in their blood. They need to take saline solution as intravenous injection. So that's a good example for a liquid solution, saline solution, saline solution. Not only the solution is saline, but its concentration is definitely 0.9%. 0.9% saline solution is needed for the intravenous injection of some patients. Why we are keeping 0.9 as its concentration? Because the concentration of our blood plasma is also 0.9. Okay. One more thing is there, an antifreeze, a mixture of ethylene glycol and water. 35% of ethylene glycol is needed for that mixture, that used as an antifreeze in the radiators of cars for cooling it because of it, the colligative property. Depression in freezing point, it can what it means decrease the freezing point below 0 degrees centigrade. So it's used as an antifreeze. That's also 35%. Then we come to solid solutions. Solid solutions. All the alloys. If you need a solid solution, you need to take a solid as a solvent, the major component. Here a very good example of this one is steel. The solvent or the major component in steel is iron, and it's a mixture of iron and carbon mainly, and it contains traces of chromium and nickel. Chromium and nickel with it. And what here means, change the concentration of steel, change the quality and characteristics of steel for different usages. Steel have a vast range of usage, from surgical steel to building block, that means the backbone of buildings. Then surgical steel needs 13% chromium in its composition. 13% is a definite one. So that is solid solutions, almost all the alloys. And then comes gaseous solutions. Gaseous solutions. You know scuba divers. Scuba divers in depth of water, they don't get dissolved oxygen from water, so they need oxygen with them. They carry oxygen in tanks. In addition to oxygen, the mixture contains helium and nitrogen with it. A perfect mixture. That's also helium, nitrogen and oxygen. It's a mixture of helium, nitrogen and oxygen. So now we came to liquid solution. Examples, we can write the examples only. That's the saline solution. Saline solution. And the concentration is 0.9%. 0.9%. And steel. For surgical steel, 13% of chromium in addition to iron and carbon. 13% of chromium. And for mixture, gaseous solution in diverse tanks, in scuba diverse tanks. It contains 11% of helium, 56% of nitrogen and 36% of oxygen, only 36 or it's 32, sorry, 32 percentage of oxygen. This is the concentration of the gaseous mixture. And here we can give importance to these numbers. 0.9%. Why it's 0.9? Why, if it's above or below, there is no that means significance for this solution. And 13 percentage here, and 11, 56 and 32, these numbers are very important. Therefore, first we are considering solution and then goes to the problems of this one. Here we first need to overcome the problem of keeping a significant concentration for a particular usage. So concentration terms are very important. Concentration of solutions. First, mass to mass percent. Simply we can write it as mass percentage. If the solute and solvent both are in solid state, we can take the mass of both and we get a mass percent. Second, volume percent. If both are liquids, we get volume percent. Third, mass to volume percent. Mass to volume percent. In case of both the solid state and the liquid state are present in solution, mass to volume percentage is there. And the fourth one is parts per million. Parts per million. If there are traces of quantities, very minute quantities in solvent, we can take parts per million as its concentration term because it's very trace in quantity, like the dissolved salts in ocean and pollutants in atmosphere like carbon dioxide, concentration of carbon dioxide, nitrogen dioxide, sulfur oxide, etc. Very traces of compounds are present, and it's not what means convenient for calculation, and for its convenience we are magnifying this to 10 to the power 6 million, 10 to the power 6, and we are getting parts per million. Next is molarity, capital M. Molarity is the concentration term, number of moles. It considering number of moles. You know what's a mole, and it's a count. It's a count of 12 gram of carbon atom. How many atoms are present in 12 gram of carbon atom? That's a count. That's Avogadro number. 6.022 into 10 to the power 23 atoms are present, and that's known as 1 mole. A number of moles. That counts number of moles in volume of total solution. That's molarity. So we can represent it as moles per liter, because volume is in liter of the total solution, volume of the solution. Moles per liter is molarity. You look here, we are taking volume. But you know that volume is temperature dependent. If temperature varies, the volume also varies. Therefore, molarity is a temperature dependent concentration term. Next comes molarity. Here, molality. That means small m is there. That's also the number of moles of the solute, but with mass of the solvent. Mass of the solvent, that is moles per kilogram. Moles per kilogram of the solvent. Here it's total solution, here it is solvent. Here is volume and here is mass. It is temperature independent because mass is independent of temperature. It will not vary with temperature. or range of temperature, we can take this concentration term molality small m. These are the main concentration terms with solution. And our today's total assignments from the first part, the assignments are what's alkene, and the second one is what alchemist gives you as a chemistry student. Third one, is there any resemblance between Santiago and our writer Paulo Coelho? And the fourth one is which are the practical applications of these concentration terms? Students, we must give importance to practical application, because if we need a solid solution or a gaseous solution and or a liquid solution, and we have a particular usage, we must know the concentration of the components present in it. So concentration is very important, and in next class we are doing problems related to this concentration with the answer of our assignments.